Welcome to CINS 2020 Module 1, an Introduction to Business Programming. In this module, we'll provide an overview of computers and computer information systems. Specifically, you'll learn about computer information systems and their purpose, components of an information system, that is, what makes up an information system, the information processing cycle, which shows us how data is manipulated or translated into information, and finally, we'll talk about different categories of information systems. Let's start off first by defining what a computer information system is. Many times you may actually hear a CIS referred to as a business information system, or an information system, or even a management information system. No matter the terminology, the definition is the same. It is a set of components that interact to facilitate the creation and dissemination of information for decision-making purposes. Now let's think about the bold words. It's a set of components. It's a group of things that work together. That means interact, to allow for or to facilitate the creation and the communication or dissemination of information. And then the ultimate purpose of computer information systems is to help us make better decisions. So in essence, a computer information system is a group of things that work together, that manipulate data, that create it into some form of information and then communicate it in such a way that we can use it to make better decisions. Let's move now to gaining an understanding of computer systems and that initial set of components. Most computer-based information systems consist of 5 components: hardware, software, data, people, and then networking communications. Let's look at hardware first. Hardware includes those things that we can see. It's equipment associated with the computer. It's things such as the monitor, a keyboard, a speaker, a mouse, even a microphone. It's things that we can touch and feel. These things don't know how to work without software, which is the second component. Software is simply computer instructions. It tells the hardware what to do. Without software, hardware is useless. Programs, which is what we usually refer to software as, are really instructions written by programmers that tell a computer, that tell the hardware exactly what to do. Programs are usually categorized in one of 2 ways: application software or system software. Application software includes things such as word processors, spreadsheets, payroll, inventory control systems, or even games. Whereas system software includes things such as operating systems like Windows, Linux, or Unix. The third component is data. Data is really the raw facts. It's the raw ingredient that we use to manipulate, to process, to do something to create information. So it's what goes into our system. We manipulate it. It's raw facts, numbers, figures, pictures, sound, anything that you can consider going into a computer system that we will manipulate, that we will process, and turn it into something that's useful. And of course, that useful information is what we're using to make better decisions. The fourth component of a computer system is people. And I've listed several different roles that people might play. Programmers, of course, are the people that write the sets of instructions. End users are people who use the computer-based information system. Owners maybe are managers. They're business owners. They're the people who make the decision to either purchase a computer information system or to provide the resources necessary to build the information system. Analyst and database analyst are specific roles that people might play in addressing problems. They do analysis to come up with solutions. They find out what all is in the environment. What do we need to pay attention to? What solution can we come up with to help solve our problem? And network engineers and administrators work with the many forms of telecommunications equipment and network infrastructures that we might have. And finally, the fifth component is the networks and communication technology. This could be networks, wired or wireless, could include things such as shared drives, cloud technology, which is storage location that is in a different location. And then once information has been created, networking technology allows for it to be shared or communicated for decision-making purposes. So it's kind of the backbone of the information system. It is what allows us to share the information to people for decision-making purposes. We've talked a little bit about how computer systems work. All computer hardware and software really work together to accomplish four major operations: input, processing, output, and storage. Input includes gathering our data items such as text, numbers, images, and sound, and getting them into a form that the computer can understand. Machine language. Once it's in the computing system, then processing occurs. This is going to include things like calculations and comparisons performed by the central processing unit, a key hardware piece of equipment. Finally, after it's processed, we have output, and that is the information. So resulting information that is sent to devices such as a printer, plotter, monitor, or even speakers after processing. It's what's used for making decisions. And finally, storage. Data that is stored in a machine-readable form on devices such as hard drives, optical drives, USB devices. A cloud-based device is accessed through the internet. And today, more and more people are using cloud technology for their storage needs. The big difference between output and storage is that output is in a form that humans can understand, whereas storage, the data is really stored in a machine-readable format only. Humans cannot understand that data at that point. Let's look at the information processing cycle in detail. From our previous slide, we talked about the information processing cycle, including four components: input, process, output, and finally storage. This model shows us how our input, which we referred to as data, enters into the computing system. It's processed, and hopefully our output is going to be something that's useful to us. It's going to be information, something that we can use to make better decisions. These four steps: input, process, output, and storage, make up what is known as the information processing cycle. We have data that, again, can be raw facts and numbers. It can be sounds. It goes into our computing system where it's processed. It's manipulated. It's turned into something else. Hopefully that something else is information. It's something that's going to be useful to us for making decisions. Let's look at it in a little more detail. And this is really going to help us understand how a computer processes data into information. A couple of things that are very important. First of all, it's important for us to understand this process as a programmer, because when we write programs, we are going to take data, that's our input, and we've got to be able to identify that data and represent that data in our program. Once we have our data identified, we need to know how to process it. We need to know what algorithms we're going to use to manipulate that data. And most often in a program, we start with output. We know what information we're trying to create. So we know what we're seeking, and then we work backwards to identify the data, and then process that data to get us that information. Then finally, as a programmer, we want to know in what format do we need to store that data for future use, or even that output. Now, a couple of important things. We have input that goes into the computer system. It goes into a form. It's called bits of information, BITS, and it's really either a 0 or 1, and more specifically, it's an on or off state. A computer is really a dumb device. It only understands two things: off and on. That's it, nothing else. So when we use an input device, such as a keyboard, and we hit the number 9, the computer has no idea what the number 9 is. The keyboard, however, sends a series of on and off bits to represent 9. In fact, 00111001 represents the number 9 in the computer system. And these are actually electronic pulses. A 1 represents a pulse. A 0 represents no pulses. 8 of these represent a byte of information. So 8 bits is 1 byte. 1 byte represents 1 character. So 8 bits is 1 byte. 1 byte represents 1 character. Now, very quickly, all forms of input go into the bottom of the box. This is called memory, specifically random access memory. Random access memory is volatile, which means the electricity has to be on to maintain the information. If you have something in RAM and the computer goes off, whatever you had in RAM disappears. But all forms of input go into RAM. All forms of output come from RAM. Output being information or storage. At the top of the box, we have something called our CPU, our central processing unit. And that is really the brain of the computer. The brain of our computer that takes over. It goes down into RAM. It gets an instruction. It decodes it. It executes it. And it stores it. Those steps make up what is known as the machine cycle. Fetch, decode, execute, and store. So, an instruction goes in as input, data goes in as input. It's all stored in RAM. The CPU, specifically the arithmetic logic unit, the ALU, takes over and runs the machine cycle. It fetches, it decodes, it executes, and it stores. And finally, whenever output is ready, it comes from RAM and goes either as output or storage. So that's a very simple explanation of how data is processed into information through the information processing cycle. Continuing in our discussion of computer systems, the computer inside the processing box is something called the motherboard, and on the motherboard is a bus, and the bus is the transportation channel. All these electronic pulses need to be able to get from one place to another. They follow the bus path. So the bus is the transportation channel. The system clock and the machine cycle, which we just talked about, provides the synchronization. The system clock generates a pulse, much like a metronome does for learning how to play the piano. It allows us to keep time. So every time a pulse is generated with the system clock, the pulses can move, or the bits can move from one place to another. We also talked about the CPU and the arithmetic logic unit, which is the brain of the computer. We talked a little bit about computer memory. It's our temporary internal storage, also known as RAM. And just like we talked about in the previous slide, it's volatile. It's lost when the power is off. Sometimes we need permanent memory. For example, when the computer is first turned on, it needs a set of instructions so that the hardware knows what to do. Those instructions are stored in ROM, and there are many different versions of ROM. There's PROM, there's EEPROM, there's EEPROM, but let's stick with ROM for now. It's read-only memory. It's non-volatile, which means that it does not have to have electricity to maintain its instructions. Okay. The last thing that we'll talk about in this module is the various types of information systems that we have. And we can use a pyramid model to help us understand the types of information systems and their role. At the bottom of the pyramid, we have something called transaction processing systems. And transaction processing systems handle the type of things that happen on a daily basis. They may be tracking transactions in a grocery store, things that happen on a regular basis, day-to-day transactions, minute-to-minute transactions, so short-term in nature. In the middle, we have something called MIS, or Management Information Systems, sometimes referred to as Management Reporting Systems. We also have something called DSS, which is Decision Support Systems. And at the top of the pyramid, we have something called Executive Information Systems and Expert Systems. Expert systems are those types of programs that really make decisions for us. They try to mimic the human thought process and decision-making process. Now, what we're really looking at are a couple of things. Type of activities and types of problems. And these are two things that we use to categorize the various types of information systems. At the bottom of the pyramid, we have structured type problems, which means there is an answer. We can program that answer. The problem is solved the same way every single time. In the middle of the model, we have semi-structured problems, which means part of the answer can be programmed. And finally, at the top, we have unstructured. There is no one right answer. There may be many answers, but no one right answer. Finally, on the type of activities, these are type of management activities. We have operational activities at the bottom. You can think of this as a grocery store manager, someone who manages the daily operations. They're going to need very timely information, very detailed information. In the middle, we have tactical type activities. These are midterm, maybe several months or maybe a year type activities. And then finally, at the top, we have strategic activities. These are very long-term activities. Where are we going to place the new warehouse? Those types of decisions. So, for strategic type activities and unstructured problems, we might develop an expert system or an executive information system. For tactical type activities, which are semi-structured problems, we would use these types of information systems. For operational activities, which are structured problems, we would create transaction processing systems.